Let's talk about polynomial inequalities. Polynomial inequalities work the same way, really, as quadratic inequalities. We want to move everything to one side of the equation. We want to set it equal to 0 and find x-intercepts. I call those boundary points. Then we're going to place those on a sign chart, test each interval, and then we can use that to help answer the question. So I want to start with a picture. So let's say we have this polynomial. And we want to find some solutions to some problems. Let's say we want to know where f of x is less than 0. So if we're looking at less than 0, well, that's happening on this piece here and here, and it's happening here. Now we want strictly less than 0, and we always use the x values to help us find this. So this is happening from -1 to 1. That's that middle piece here. And then it's happening from 2 to infinity. B is asking it, where are we greater than 0? Well, that's happening here, and then it's happening here. So it's happening from -infinity to -1, which is that left-hand piece. And then it's happening between 1 and 2, which is that piece in between. So if we have a graph, we can look at it and determine where is it above and below the x-axis. Because that's really what that guy's trying to say. Now let's look at some other problems. Number 10, we want to know where is f of x less than or equal to 0. So I'm going to set up my inequality here. We want it less than or equal to 0. So we need everything on one side. We're good there. It's factored. We're good there. So now we need to set it equal to 0 and find those boundary points. So we've got x equals 0 for one of them and -2 for the other one. Those numbers are going to go on a sign chart. So now let's plug in numbers, and I'm going to use that factored form there. So we're testing some numbers now. If we plug in -3, we're going to have a -3 times a -3 plus 2 squared. So this is going to be a negative, and this is going to be a -1 squared. But remember, -1 squared is going to be a positive. So a negative times a positive will give us a negative. And remember, all we care about is the sign. So now let's plug in something between here, like a -1. So we have -1 times -1 plus 2 squared. So this is -1 times a +1 squared. So we have a negative times a positive, which is a negative. Now, the reason we have the same on both sides, the same sign, because of the multiplicity. That multiplicity of that root is 2. So that graph is touching the x-axis there, but then it's going right back. So both sides of the graph at that value are on the same side, and they're both below the axis. And now let's plug in 1. If we plug 1 in, we're going to have 1 times 1 plus 2. So this is a positive times a positive, which is a positive. So we're positive there. So this graph, if we were to draw a picture, is below the x-axis here, and then it comes up here. So where are we below? Well, we're below on this piece and on this piece. This is a continuous function, so we can put these two pieces together. So we would say it's from -infinity to 0 inclusive. Now, what if we were to change it? What if it said x times x plus 2 squared is strictly less than 0? Well, if we're strictly less than 0, then now we cannot include that -2. So our answer would be slightly different. Then we would have two different intervals. And we would have to use parentheses there, not brackets. So that would be the answer. So you can see the difference in just that sign and how it would change the problem. 12 is going to work the same way. We want to know where f of x is greater than 0. So our f of x is x minus 1 times x plus 3 quantity squared. We want greater than 0. So let's find x-intercepts. So x is equal to 1, x is equal to negative 3. Those are going to go on our sign chart. And then we're going to test the intervals. Let's plug in a negative 4. And I'm going to use that factored form again. So negative 4 minus 1 times a negative 4 plus 3 squared. So this is negative 5 times a negative 1 squared. So a negative times a positive would be a negative. If we plug in 0, 0 minus 1 times 0 plus 3 squared. So that would be a negative 1, so a negative. 3 squared is a positive, so that would be a negative. Okay, that makes sense because the multiplicity is 2 for x equals negative 3. And then if we plug in something bigger than 1, like 2, we're going to have 2 minus 1 times 2 plus 3 squared. So that's a 1 times a 5 squared, which is going to give us a positive. So in this case, we want greater than 0. That's going to happen here. So the answer is 1 to infinity. And then let's look at that last one. And I'm going to copy it on the next page. So this one is not factored for us. We need everything on one side of the equation. So, there. Now, let's factor. We can factor a 3x squared out. And that's going to leave us with an x plus 5. So, there's our factored form. Now, we need to find those boundary points, those x-intercepts. So we're going to get 0. Notice the multiplicity there is 2. And we're going to get negative 5. Those have to go on a sign chart. So let's test some numbers. If we plug in a negative 6, we're going to have 3 times a negative 6 squared times negative 6 plus 5. So that's 3 times 36. Times a negative 1. That's going to give us a negative number, so we're going to have a negative there. Let's plug in negative 1. We just need some number between here. It doesn't matter which one we pick. So 3 times negative 1 squared times negative 1 plus 5. So 3. This is a positive 1. This is a positive 4, so we're going to get positive there. And then on this side, we're going to get a positive also because the multiplicity of 0 is 2. It's an even multiplicity, but let's just show it for fun. If we plug 1 in, we have 3 times 1 squared times 1 plus 5. So we have a positive times a positive times a positive, which will end up being a positive. Now the question asks, where are we less than 0? We're less than 0 here. So our answer would be negative infinity to negative 5. And we can use this to help us find domains. So let's do one of those. So what if we had something like this? We talked about domains of square roots before, but now we've got something a little more complicated under that radical. So to find that domain, we would need to set that radicand greater than or equal to 0. So that's the inequality we want to solve. Now, this guy factors. That's x squared minus 4 times x squared plus 4. And that first one actually factors. That's a difference of squares. X plus 2, x minus 2. So there's our fully factored form. So if we set each of those equal to 0, we're going to get negative 2 for the first one. We're going to get 2 for the second one. And we're not going to get anything real for that one. So these are our x-intercepts. Those are going on a side chart. So that's splitting that into 3 pieces. So now let's test. If we plug in negative 3, now I'm going to use that fully factored form. So we're going to have negative 3 plus 2, negative 3 minus 2, and then negative 3 squared plus 4. So this guy's going to give us a negative. This is going to give us a negative. And this is really 9 plus 4, which is a positive. So a negative times a positive is a positive. Now let's plug in 0. So we're going to have 0 plus 2, 0 minus 2, 0 squared plus 4. So we have a positive times a negative times a positive, which is going to be a negative. And then to the right of 2, like 3, we're going to have 3 plus 2, 3 minus 2, 3 squared plus 4. So this is a positive times a positive. And that's going to be 9 plus 4, which is another positive. So that's going to be a positive. So we want greater than 0. So it's going to be these pieces. So then the domain for this function would be negative infinity to negative 2, union 2 to infinity. So there's our final answer for that one.